In last video we have seen the representation of the electrochemical cells. We have also at that time we also take this re again. Re again is not again. Then in this, at the anode is at the left side. At there we have used the zinc, and this is a negative electrode. And at the anode oxidation occur, and at the cathode reduction occur. It's a positive electrode, and it is on the right side. Okay, a vertical line or semicolon indicates the contact between the phases. Then we have you firstly we write the metal, and then metal ion, that's a zinc and zinc plus 2, or zinc or semicolon Zn plus 2, or we have write the concentration in the bracket. And cathode of the cell is represented by writing the cations of the electrolyte first and then metal. Yeah. In the second, firstly we have write the anode. In this one, firstly we have write the metal and then their ion. But in cathode, there first we write the ion and then we write the metal. The salt bridge which separate the two half cells is indicated by two parallel vertical lines. That's important. You have remember that thing. Salt bridge which separated by two half cells is indicated by the two parallel vertical lines. Sometimes negative and positive signs are also be put in the electrodes. Yes. Then now we have seen electrode potential. What is the electrode potential? When a metal is placed in a solution of its ion, the metal acquires either positive or negative charge with respect to solution. There are definite potential differences developed between the metals and the solution. This potential difference is called as electrode potential. Means there is a we have metal is placed in solution. Then metal acquire positive or negative charge because it is dissociated into ions. Then it acquire the positive or negative charge. It's an obvious thing respect to solution. And that there is a definite potential differences developed between the metal and the solution. In this solution, potential is the developed. This is called the electrode potential. Okay, the potential difference is established due to the formation of electrical double layer at the interface of metal and the solution. Okay, the development of negative charge or positive charge can be explained as follow. Where a metal rod is dipped in a salt solution, following two changes can occur: plus and yeah. When the metal lose the one electron, then it is acquire the positive charge. And when the electron gain or it's have the excess of the electron, then it's occur the negative charge on the electrode. That's it. That's the same thing. That's a metal ion or solution gain electrons from the electrode, leaving a positive charge. Yeah. In the beginning, both of these changes occur with a different speeds, but soon as equilibrium is established, in practice, one effect is greater than the other. In reaction A, this is both of the cases potential difference is set up. The magnitude of electropressure of metal is the measure of its relative tendency to lose or gain electrons. Okay, now this one is important. That's electrode potential. Definition of electrode potential: electrical potential difference set up between the metal and its solution. Electrical potential difference we have lastly seen. The metal is placed in the solution and then it dissociate the metal and it's form the ions positive or negative as per this dissociation or their affinity. Then there is produced the electrical potential difference between the metal and the solution. It is called electrode potential. Factors affecting the potential. Which factors affected on the electrode potential? First one is the nature of the electrode. Which type of the electrode is there? Second one is the concentration of ions in solution. Concentration of this ions is produces in the solutions metal ions. This is the second factor affecting. And third one, this is a temperature. Temperature is also affect the magnitude of the potential. Depending on the nature of the metal electrode to loss or gain electrons, the electrode potential may be have two types: oxidation potential or reduction potential. Oxidation potential, it is measured of the tendency of electrode to lose electron or get oxidized. Yeah. Means oxidation means increase in the positive charge, and reduction means decrease in the charge. There is a, when positive charge increases, when it lost the electrons, then it get oxidized. And reduction means when it is gain the electrons, it is a negatively charged and then it is reduced. Then next one is the EMF cell potential of the cell. It is not possible to measure a single electrode potential directly. Only the difference in potential between two electrodes can be measured experimentally. It is therefore necessary to couple the electrode with another electrode whose potential is known. The electrode is known as the reference electrode. The EMF of resulting cell is measured experimentally. We have not a practically, we theoretically can say it is measured as experimentally. The EMF of the cell is equals to the sum of the potential of the two electrodes. Sorry, EMF of a cell is equals to, it's a wrong, it's a sum, is not it a difference of the potential of the two electrodes. That's the EMF of the cell is the E cathode minus E anode, is the E cathode minus E anode. Okay, EMF is equals to reduction potential of cathode at the reduction potential of cathode side, then minus reduction potential of anode side. Cathode is at present on right side of the of the electrolytic cell. There are two half cells, that's one is left side and one is right side. Right side electrolytic half cell is called as a cathode, and at the left side it is a anode. That's E cell is equals to E right minus E left. Okay. Then that's a last point is important. On this questions also asking in the exam, a cell's reaction will be feasible only if the value of E cell is positive. If the value comes out to be negative, the cell's reaction is not possible and the electrode will have to be reserved. In order to bring about the cell's reaction, the EMF of cell potential of cell can be measured with the help of potentiometer. देखो, a cell's reaction in which are feasible only if the value of E cell is positive. When we have find the E cell value from E of cathode minus E of anode, that's the formula. We have used the value and then we have got the positive answer. Then reaction is called as a feasible. And if this value comes out be negative, then it is reaction is a not a possible, or it is a not a feasible, and there is electrodes will have to be reserved in order to bring about the cell's reaction. That's the meaning of that. When it is positive, it's a feasible reaction, and when this is a negative, it is a not possible or not feasible. Okay, the EMF of a cell potential of a cell can be measured with the help of potentiometer. With the help of potentiometer we can measure the EMF. Okay, measurement of a electrode potential. How many slides? So many. That's one complete. Then now measurement of electrode potential. Measurement of electrode potential. The electrode potential of electrode can be determined by combining it with other electrode to form a complete cell. Electrode potential of electrode can be determined by combining it with other electrode to form a complete cell. The electrode which is used to determine electropotential of a electrode is called as reference electrode. Okay, this one is important statement number 2. That's the electrode which is used to determine the electrode potential of an electrode is called as reference electrode. Means इलेक्ट्रोड पोटेंशियल को मेजर करने के लिए जो इलेक्ट्रोड यूज़ किया जाता है उसे रेफरेंस इलेक्ट्रोड कहते हैं. स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड SHE standard hydrogen electrode is it most commonly used reference electrode is it okay. It is used most widely. The other reference electrodes are calomel electrodes, silver chlorides electrode. But widely used is the SHE standard hydrogen electrode. It's important. And the electrode potential of electrode is determined by connecting the half cells with SHE standard hydrogen electrodes. The electrode potential of SHE is taken is a 0 volt. The EMF of cell given the value of electrode potential of a given electrode. There is a certain limitation of hydrogen electrode. It is difficult to maintain the pressure of H2 gas at 1 atm. Moreover, the electrode is radially affected by the compound of Hg, arsenic, sulfur, and oxidizing agent like Fe plus 3, amino4, or chromide ions, etc. like that. That's a electrochemical series. The electrochemical series is built up to arranging various redox equilibrium in order to standard electrode potential, redox potential. The electrochemical series is built up to arrange various redox equilibria in order to their standard electrode potentials. The most negative inert value are placed at the top of the electrochemical series. At very most electrode potential, that's a more reducing power. It's a negative value, most negative value and most at the top of the electrochemical series, and it is a more reducing power. We can see in this series there's a where it is a theoretical points. That's the next one is comes in the electrochemical series. Different metals are arranged as per their redox equilibria above the below hydrogen equilibria is the series. Okay, like here we can see it is a reduced form, means there is a highest reduced power in this oxidized form and electron. When we it is oxidation is plus 1, and when we gain an electron then it is reduced. Oxidation is converted to reduced form, and its value is negative. That's we can see here, it's a negative, and there is a standard electrode potential for the H2, that's 0. That's important. And there is a we can only remember some value from that, like Pb, Sn, nickel, cobalt, cadmium, Fe, and zinc, some that. And from that side, that's a Cu plus 2, Fe plus 3, Ag plus, or some this value are you remain in your mind. That's not a for learn, but for your reference you can learn that value or not be also. It's not important so ever, but value of H2 is a standard electrode is a 0. That's one important. And some upper side is a 2 3 you have remain mind, and at the lower side you have remain 2 3 is in your mind. Application of electrochemical series. That is important. Relative strength of oxidizing and reducing agent. The electrochemical series helps in predicting the oxidizing and reducing ability of a substance. In the electrochemical series, the elements are arranged in order of their increasing reduction potential. They increase their reduction potential on the upward side. This there one on that side, and hence the elements situated at the bottom of the series have a greater tendency to reduce. They are good oxidizing agent. The elements at the top of the table have a low reduction potential, have a lesser tendency of getting reduced. Consequently, they may get oxidized and good reducing agents. And this is a good reducing agent, opposite more reducing agent, and there is oxidizing agent. Okay, there is a calculation of EMF of cell. That's a formula we can see early. That's what E cell is equals to E cathode minus E anode. E cell is equals to E right minus E left. That's yeah, right minus left. Yeah, no, that's one, huh? And predicting spontaneity or feasibility of reaction, we can see value is a negative. If positive it is a feasible, or negative it is not possible for this reaction, it is a not feasible, we can say. There is we can see reaction will be uh, feasible or spontaneous. Feasible or spontaneous when the cell is as a calculated above should be positive. There is we can see positive, and negative it is a non-spontaneous or not feasible. Okay, that's the last slide of our today's lecture. That's application of electrochemical series to predict whether a metal will react with acid to give H2 gas. Those metals whose reduction potential is less than that a reduction potential of hydrogen can liberate H2 gas. Such metals are placed above H2 in the electrochemical series. Yeah, in this electrochemical series we have seen that some elements are placed above, some are below. The hydrogen having higher reduction potential has a greater tendency to accept electron as and get reduced. Metal placed below means there is hydrogen have a higher reduction potential as compared to above side elements, and as compared to lower side there are lower electrode potential, that we can say from that total electrochemical series. Okay, and replacement of tendency. The metal on the top of the electrochemical series has the tendency to replace the one below. It forms its solution. This is because the metal placed at the bottom has a greater reduction potential and has a greater tendency to accept electron. For example, the reduction potential of a copper is greater than zinc, hence copper plus 2 ions have greater tendency to accept electron. Okay, means we only conclude from that the from hydrogen in the electrochemical series above of that, above having the lower electrode potential from up to top, and below the down increases the electrode potential, means positive always increases and negative will increases, but